All right. So this is chapter 7D, and we're dealing with equations with the pronumerals on both sides. So if you don't know or if you don't remember what pronumerals are, they're just another word for variables, aka the letters. So we're just gonna deal with that. Learning aim. Gonna solve equations with the pronumerals on both sides, and then hopefully by the end of this video, you can solve these kinds of equations. Okay. So previously in chapters 7a, b, and c, I've only taught you how to solve equations when the variable is on one side only. It could either be on the left hand side or the right hand side of the equal sign. But what happens if you see the variables on both sides? Well, it's pretty easy. What we're going to do is mm, make it to one side only. That's pretty much the goal. So if you have a look here, I have an example right here where I have the pronumeral on both sides. So as you can see here, our variable is the letter X here. We see that it's highlighted right there. I'm going to try and force it to one side. So you got to think of an equation like a balance scale. Just think of it like that. If I am going to take this 3x and remove it from the right hand side, if you imagine that it's a scale, you can see that the scale is going to shift in the balance. So what that means is one side will be heavier than the other if we remove the three x's on the right hand side. Now the whole goal is to keep it even. So we want the scale to be the same level as it is now, even after like we make changes to the equation. So just over here, if I'm going to take out three of these, if I'm going to take these out, if I plan on keeping this balance, then I should also take three out from the left hand side as well. And all I'm left with is two x's. So in our equation, it just becomes 12 plus 2x equals 16. As you can see, the 12 doesn't change, the 16 doesn't change, and then I just have the remaining x's there. So once you reach this stage, you can just solve like normal. Okay. Alright. So I'm gonna go through these examples here. Now, a habit of mine is I always move the variable to left hand side. That's my habit, okay? But you can also move the variable over to the right hand side. That's perfectly fine. You just do whatever you feel most comfortable with, okay? But ideally the left hand side. The reason why is because let's just say, for example, if I write something like this, if I write, let's see here, 8 equals A, if you just compare that, if you just look at that and then compare it the other way around, I'm pretty sure most people would say this one looks more nicer to read than anything. So that's why I always say just have the variable on the left hand side. But what a lot of people do not know is if you write your answer like this, you can just rewrite it like that. So if the variable that you solve is on the right hand side, you can just write it again, but write it on the left hand side. So not a lot of people know that fact. But I'm just gonna do my bad habit, and that's what I'm gonna do every single time, okay? So I have here 7t plus 4 equals 5t plus 10. Just following the logic from the previous slide of the balance scale, I need to remove this. I'm going to remove the 5t because that's on the right hand side. So if I plan on yoinking it out, I also have to remove it from the left hand side as well. But the best way to do that is if you have a look here at the 5t, is there a sign there? Is there a sign there? So just ask yourself that. Is there a sign? If no, then it's a plus. It's a plus sign. And then if it's yes, you would have seen a negative sign right there. Okay? You would have seen the negative sign in front of the 5t already if there was a negative. But because you don't see a sign, you must assume that it's a plus. You must assume. So, what I've taught you previously is to apply inverse operations. So, if you don't remember what it is, I'll just do. So, if I see a plus sign there, the inverse of plus is minus. Vice versa, if I see a minus, I'm going to plus it. If I see times, I'm going to divide. And if I see a dividing sign, I'm going to, sorry, not minus, I'm planning on timesing it, okay? So that's all you got to do. So because we plan on applying inverse operations right there, I'm now going to subtract 5t on both sides. If I do that, it becomes 7t plus 4 minus 5t on the left hand side equals 5t plus 10 minus 5t. So what I've just written here is me actually applying the subtraction of 5t on both sides. And then you just collect like terms like normal. Um, so I have here 7t minus 5t. That just becomes 2t. Now the plus 4 doesn't change. So I'm just going to write that down. And on the right hand side, 5t minus 5t, it becomes 0. So it just basically disappears. And then whatever's left over on the right hand side, I can see that it's just positive 10. Okay. Now, I have noticed that a lot of you will see this and be like, oh, that's 6t, by the way. But I just ask you, like, where do you see the like term? Like, there's no like term whatsoever. So you should not be adding these together. Okay. This is a mistake that I found in people's work. So I would like for people to avoid this as much as possible. Now, just remember when we solving, we want the variable to be isolated. So just remember that's the goal here. So I am going to get rid of this plus 4 on the left hand side. So if I remove this plus 4 on the left hand side, I must also do it on the right hand side, just like that. Comes 2t plus 4 minus 4 equals 10 minus 4, like this. Now, on the right hand side, I have 10 minus 4, which equals to 6. And on the right hand side, 4 minus 4 becomes 0. So they just disappear. And all I'm left with is 2t. And now I can see that this 2 is attached to the letter t. Just remember 2t just basically means 2 times t. So if we apply the inverse of timesing, we are now going to divide both sides by the number 2, just like that. So it becomes 2t equals 6, divide both sides by 2, and then I somehow end up with t equals 3. The reason why t equals 3 is because if I do 2 divided by 2, this just becomes 1t, and we typically don't write 1t at all. So we just write the letter t. That's why on the left hand side it's the letter t. And then 6 divided by 2 is just 3 on the right hand side, okay? So that's all you want. So that's how you would do it. All right, let's do the second example. 2u equals 7u minus 20. Um, I'm just going to move the variable over to the left hand side because that's what I always do. So let's have a look at the sign in front of the 7u. No sign, so we must assume that it's a positive. And because we are trying to get rid of the 7u, I'm going to apply the opposite operation of it, or the inverse operation. That will be minus 7u. Okay, so let's just go ahead and do that. Hey, what happens here is you collect the like terms of 2u minus 7u. Um, so you just go 2 minus 7, which is just negative 5. And then the 7u on the right hand side disappears completely. And then on the right hand side, you just end up with the number 20. Now, this is another mistake. A a mistake that people make is they'll see that negative sign there. And a lot of people will actually say that they want to plus 5u, which is not what you ideally want because remember, we're solving for the letter u. And like, you just have to remember that negative 5u just means negative 5 times u, just like that. So what we should be doing is actually dividing by negative 5, okay? That's ideally what we want. So I'm going to now divide both sides by negative 5. Now let's just break down the left-hand side very slowly. I have 5 divided by 5, which is just 1. And then you just look at the sign when you divide the negatives together like that, it just becomes a positive. So that's why my answer here becomes positive u. And then 20 divided by 5 is 4. But let's just double check the sign. I have a positive divided by a negative. So that means it's a negative number, okay? So my answer is u equals to negative 4. Oh, whoops. Can I go back? No. Oh, oh, oh. How do I fix this? No. Okay. There we go. I'm going to give you some time to try this out and then I'll have my solutions up, okay? Okay, so these are my solutions here. Please have a look, compare it to what you've got. Um, okay. These are the questions you should do. Please go through every single one. Make sure that you're doing it correct. If you have any questions in regards to the question, please let me know so I can help you out next time we are in class. Take care.